going to start with, I think, a video. Yeah. Usually open it up that way. Some of the stuff we've been up to. Okay, great. So welcome, everybody. I'm Brad Montier, and I lead the Business General Aviation and Integrated Systems businesses for GE. And this year, we're going to do something a little bit different. We're going to start with a program review, then we're going to talk about our services, and then we're going to dedicate a large portion to additive manufacturing. So with me is Mohammed Al-Ashami. Mohammed is the Vice President of Additive for the General Electric Company. And up until a few months ago, he was the Vice President of Engineering for GE Aviation for all of the products. And Mohammed's fingerprints are on the airplanes that you guys probably flew in here. Many of you flew in. So Mohammed, all the way from the GE90 engine. Mohammed was the chief engineer on that. The GE9X on the 787. The Passport, the HF120 GE Honda joint venture. The LEAP engine, the GE9X that's going to be on the 777X. Mohammed is the man in engineering for aviation, for the industry, I believe. So Mohammed switched roles about a month ago, and he's now going to explode the additive manufacturing for all of GE. And the ATP, the Advanced Turboprop, has a very large additive content, and so Mohammed is going to walk through some of that. This is the first time that GE has ever revealed this kind of detail about our additive program, which has been going on for a decade. And then next to Mohammed is Tom Hofer, and Tom is the head of the Business General Aviation Customer Service and Support and the commercial aspects of our BGA division. And Tom's going to talk about some exciting things that we're doing there. So the other thing I'll just mention is that, well, I'll mention that a little bit. Just told you with a little intrigue. So I'm going to do a quick review of some of the programs just to give you a status of where these are. So the first one is the Passport. We delivered the engine to Bombardier for the Global 7000 in March of this year. The engine's already been through ground runs, they're doing testing, and we're waiting for the airplane to get in the air. So that's great. Since last year at this time when I spoke, we have just about doubled the number of hours and cycles that we put on the engine test. And our target is to have 4,000 hours and 8,000 cycles at entry into service. We have a Passport engine. We actually have one of the 10 development engines in the stand down below. So some of the things I've talked about in the past about the 52-inch titanium Blisk fan and the Oxox ceramic parts that are on the mixer and the nozzle and some of the other things you'll be able to see it, I think you'll be pretty impressed with it. And so now I'm going to turn it over to Tom. He's going to talk a little bit about our services.
Thanks, Brad. So a quick update on our On-Point service program, which I think most of you are familiar with. We continue to see really solid growth in the number of aircraft that are covered. You see 200% growth since 2010. Roughly half of the CF-34 powered business jet aviation fleet is under our On-Point coverage. And I think the clear the reasons for that, either the financial advantage that most of you are familiar with, the predictable cost, no transfer fees, provides a very secure investment, which has shown with our appraisers group that we work with closely a much higher residual value on that aircraft when it comes time to sell. The peace of mind with global support, we've expanded our global support network up to 38 service centers now around the globe, so no matter where our customer is, he or she can reach one of our service centers, if not a GE facility close by. And our dedicated account reps, we've grown the organization substantially. We now have almost 20 dedicated field service engineers and account managers solely focused on the business and jet aviation customer. We're not done though. We're taking it to the next level. We're offering a complete propulsion system coverage on the Passport engine. Advanced prognostics, I'll talk about in a couple slides here, one of our digital solutions that we're launching here at the show, and the concierge service that our customers ask for, expect, and get from GE continues to be a staple of what we do. I'll finish by saying we've expanded the On-Point program now beyond the turbofan, and we are now offering it on the H-80 powered aircraft also for our customers. We're also very humbled and proud and thank our customers for rating us #1 in both the AIN and ProPilot surveys. So we're not going to do a touchdown dance up here, but we do have some foam fingers for those that are inclined to wear a foam finger. But no, seriously, we really appreciate the recognition from our customers of, again, what we've done by growing our service center base, growing our organization, and aligning with our customers around the globe on all our products. So, digital solution. I'm sure many of you have seen the commercials around digital industrial, GE becoming a digital industrial company. And this is proof. We're launching a program here in 1Q17 of enhanced engine prognostics combined with a FOCO program. It's a total turnkey digital solution. We have aligned ourselves with Avionica, who provides a quick access recorder, which we've installed on 8 Challenger biz jets to date. Provides us with real-time data. As soon as that plane wheels hit the ground, the QAR sends all the flight data to our digital center, and we're able to then do automated, more predictive prognostic health monitoring from that flight analysis. Combine that with FOCO, which is a program designed and really airline grade, and we won't have a program that prevents even more disruptions for our customers. So, building on what our customers told us in the survey about the CF-34 being a very, very reliable engine, this will increase our operational reliability even more by being more predictive, more prognostic about what's happening with that engine. And then finally, you saw the app on the video. So we've launched our GE Support app. It's available on the Apple Store and Google Play, targeted to owners, operators, maintenance directors, anyone really who has maintenance support or questions about their GE product. As with any other app you have on your phone, it provides that 24/7 contact to our customer base, for our customer base, I should say. So no matter where in the world you might be, if you need help, if you need an answer, if you need support, AOG or not, you're literally a button away from calling a service center or GE right on your phone. And this is a tool that's across all our products. So it's for the CF-34, it's for the HondaJet HF-120, as well as the H-80 series engines. I'll turn back to Brad now. Thank you.
Okay, so a quick update on where we are with the H-Series. This product line continues to expand and grow. I think you saw in the video the first flight takeoff of the Nextant King Air with the H-Series engine with electronic engine and propeller control. If you were close and you looked at the picture, you'll see that the pilots only moved one lever per engine. And all the paperwork's been submitted to EASA, and we're expecting that probably within a week or so. The first flight was on this past Wednesday, and that aircraft is out of the static display. Not only is the engine and propeller system and cockpit controls for engines been upgraded, but had the avionics and a whole bunch of other systems in the interior. It's really quite a machine. There was a picture of the Orbis Avia. We were just awarded that, and we have a program with Icana on the Twin Otter. So now we're going to talk about the advanced turboprop. These are the numbers that we've been sharing for the last year or so, and a lot of these key features, whether it's the higher power ratio, compressor ratio, better fuel economy, the amount of power, the efficiency, a lot of this comes from our extensive use of additive manufacturing. And I'm going to turn it over to Mohammed.
Good afternoon, thanks for being here. I want to give you a little bit of background on additive. In 2011, 2012, when we started designing our LEAP machine for A320neo and 737 MAX and COMAC 919, we wanted to have a more fuel efficient product. So we started with a small part, which is the fuel nozzle. Traditionally, fuel nozzle has between 20 to 30 parts that you brace together, you weld together. What we did was we put this thing in a fashion that we could print it. And when we printed, the 25 joints went away. We realized that as a result of that, our cost went down, our weight went down, the efficiency went up, and the way the fuel was distributed and mixed with air got better and better. Then we realized that we had to use a company who actually helped us to print this, and it was Morris Manufacturing. Immediately we bought Morris Manufacturing, and that became the father of what we have as our additive today. So we didn't stop that because at that time it was just sort of one focus, let's go get this thing done, see what it can do. We were pleasantly surprised. Then we took a CT7, which is an engine that has been around for 30, 40 plus years, and we started to play with it. What can we print on the existing engine? And what we did was we took 900 parts, 900 plus actually parts, and we printed them into 16 parts. These include frames. You know, if you're familiar with the front frame, the mid frame, and the rear frame, each of them have hundreds of parts in them. So we actually eliminated a lot of interfaces, a lot of wears. When you have a bolted joint, you have wear, you have bolts, you have nuts, you have welds, you have multi-materials. All of that went away. And we simplified the bill of material. As we were playing with this, we realized that we can take 30 to 35% of the cost and the weight out. We realized that we can also open the space of the design. So, for example, as a result of this, we were able to design a heat exchanger for our G9X that traditionally has hundreds of little parts that you gotta bend and brace together. It looks like a honeycomb. We were able to print it. Then the benefactor of this actually became the ATP. So this actually was done by using 8 engineers, skunk work, hidden someplace, because I wanted to keep it hidden because, to be honest with you, I didn't know which way it's gonna go. And I didn't want the finance guys to cut the budget out as soon as they found out. But eventually we had to tell because we were getting ready to test the engine. From the day we said go until we fired the engine, it was 18 months and 2 days. And our goal was set to be 18 months, so we missed by 2 months. Apologies. So then later on, we said, what else can we do with ATP, Advanced Turboprop? Advanced turboprop was already in the design phase, so we caught it about 6 months too late. Otherwise, we would have printed a lot more out of it. But we ended up taking about 855 parts out, printing 12 parts. And I have 2 parts here I'd like to share with you. These are, this is the exhaust cone, the half exhaust cone that I brought with me. I can lift it with one hand and show it to you. What it has done is, these ridges that you see here, they are stiffeners. And I haven't done any post-processing on this yet. So we were coming down here, I said, let me just take it and show it to them. So if you touch it, it's a little bit rough, but we can polish that out. But these are the stiffeners that you can put down, but you can reduce the thickness of the material to get the increased stiffness that you want. In addition to this, this is something you like. We took 80 parts and printed into one. This is the CSUM, the cone. So if you look at this thing, traditional, again, it's a little rough. I haven't had the time to polish it yet, post-process it yet. But if you look at this thing, all the joints are gone. We printed, and the difference between, can you hear me without the microphone, I hope?
Yeah.
Okay. The difference between subtractive manufacturing and additive manufacturing is pretty simple. Subtractive manufacturing, you take a chunk of metal and you start carving it up. So you start with a huge amount of material for input. Let's say you're printing a 1,000-pound weighted engine. You'll start with 5,000 to 6,000 pounds of material. With additive, for that 1,000 pounds, you may start with 1,200 or something like that, because you just consume the material you need. Okay? And imagine the amount of energy you save and the footprint you save and all the machines you save. It's just incredible. And then traditionally you will have several materials coming together that you weld them together or you bolt them together. All of that goes away and you pick the material you want. And it serves multi-purposes. So I do have a couple of pictures I want to share with you. Don't let it drop, I'll be in trouble.
These are the actual advanced turboprop parts. These are the real deal.
Okay, so here's just to give you a feel for it. So I have a front frame, a mid frame, and a rear frame. The front frame is about 250 parts to 1. Mid frame about 300 to 1. And the rear frame is about 22, 23 to 1. I want to take the mid frame and walk you through the assembly a little bit to give you just a little bit more details on this. So traditionally,